Hey, welcome back to Physical Science. I'm just here to talk to you today. This is for Module 6. I'm going to talk to you today about acids and bases. Okay? Real nice, simple stuff. Now, if you haven't had biology yet, this is something you definitely want to get in your notes. Definitely learn, because this will actually help you further in biology. Now, if you've already had biology, you've talked about acids and bases, and this will actually hopefully be a little bit easier for you. So let's go through this, and I'll point out the things that are most important to make sure you get written down. Now, the questions we want to ask is, what is it that makes something an acid, or what makes it a base? And is there a test? Is there some sort of test that you can make the chemical go through to be able to figure out whether it's an acid or a base? And then we got answers, of course, all of that. All right, the first thing I want you to write down here is acid. Now, the basic and most truest definition of an acid says that when you take an acid and you put it into water, it is going to produce something called hydroniums. So if you look at this thing, a hydronium is an H3O. That looks a lot like water, but there's an extra hydrogen there. It's got 3 hydrogens on it. And if you look at the chemical reaction down at the bottom there, you've got HCl, which is hydrochloric acid, same stuff that's in your stomach. And there's the water right there, H2O. And after the water and the stomach or the hydrochloric acid begin to react, afterward you get an H3O, the hydronium ion, and it produces chlorine. Okay? So, and since there's that H3O on the right-hand side, you might want to circle that H3O and make sure you label that as hydronium, because you're going to be shown a whole bunch of chemical reactions, and you're going to be looking for which ones have got acids, which ones have got bases, and you're going to be looking for that H3O on the right side of the equation. That will tell you which one of those has got an acid. All right, next slide is these are some of the common acids that you're to be familiar with. You do not have to write this down. I just think it was really important for you to know that in everyday life when you're walking around, what kind of acids are being used or in industry all the way around me all the time, every day. And of course, we talked about the first one, HCl, hydrochloric, that's in your stomach. Okay? And when we did a lab earlier this year, we'd had that CH3COOH. Next one down, acetic acid, that's vinegar. Of course, if you do some decent cooking, especially with barbecue, a lot of people like to use vinegar in that. And carbonic acid, that's used in sodas. And then you've got your HNO3, that's nitric acid. That's going to be some pretty serious acid right there. Now that's been used in fertilizers. That's pretty strong stuff. You got to be careful. That's usually, the nitric acid is what eats away at the farm equipment, or if you've got lawn equipment that spreads this fertilizer out and you've got any metal parts, the parts that get corroded, that's caused because of probably the nitric acid. And then the nastiest one is down there at the bottom, which is sulfuric acid, very strong, nasty stuff. We use that in the car batteries. Okay? All right, moving on. These are very important. Make sure you write down the properties of acids. You've got to have these. I put a star and say memorize these, okay? Because you're going to be asked during the quiz and the test. You know, if you're asked, like the first one there says sour taste. If you're asked a question like, why does a lemon taste so sour? And you'll be able to say it's because of the acid, the citric acid that is inside the lemon or grapefruit or oranges, or that's in vinegar. That's what gives it that sour taste. The next one down, the bullet down, is reacts with most metals. We talked about that with that nitric acid, reacting with farm equipment, especially anything that's metal. Most acids react with metals. The third one down is kind of a confusing one, and you got to be careful with this one. There's different kinds of litmus paper. Litmus paper is a special kind of chemical paper that you use, and you dip it into different kinds of liquids to figure out whether they're acids or bases. And you use blue litmus paper, and anytime you take blue litmus paper and you stick it down into acid, it'll make it turn red. So I like to remember red acid. Okay, the next thing down is you've got a proton donor. That's just a basic definition. Acids are considered to be some sort of a proton donor. All right, moving on. Bases. A lot of times we think about this, you see in movies where you've got some sort of chemical and it's eating through something. you know, whether it's the predator and alien battling each other, and there's some sort of liquid that melts down through metals and stuff. Acid is always the one that always comes to our mind, but we need to realize that bases are just as dangerous, okay? They're just as toxic and just as dangerous. You got to be careful with them. They, when you take a base of any kind and you mix it in the water, instead of producing the hydronium, it produces an OH, which is called a hydroxide. You remember that's also one of our polyatomic ions that we had to play with. And if you look at the chemical equation down at the bottom, there we've got NaOH, okay? I had a chemistry teach me one time that, hey, anytime you see a chemical combination of your compound that's got that OH on the end, he said there's a very good chance, more than likely, that is some sort of a base. So anyways, we got our NaOH. We're going to dump that into water, so it's plus H2O. And sure enough, out on the right-hand side comes out OH. Okay, so anytime you got the OH on the right-hand side of the equation by itself, then that means we got our hydroxide, and that means whatever it was that got thrown in the water on the left must be a base. Okay, all right, moving on. Here are some common everyday bases that are around you all the time. You do not have to write this down, but it's just interesting stuff. Hopefully today sometime you put on some deodorant. You know, you put a little deodorant on so you don't smell so ripe at the end of the day. Thought we use aluminum hydroxide, Al hydroxide. That is in your deodorant. I was told one time that the whitish color that is in a deodorant or an antiperspirant, that is the part that is the actual aluminum hydroxide. Then going down a little bit farther, we got calcium hydroxide. That's used in concrete. That's part of the process of curing the concrete that they will use calcium hydroxide. Then we have magnesium hydroxide, which is used as an antacid. Okay, if you got an upset stomach, sometimes the medication or the over-the-counter stuff you use may have a little bit of magnesium hydroxide in it in order to cut down on the acid. Now, if you use too much of it or it's a high enough concentration, sometimes it has just the opposite effect and it becomes a laxative, which, if you don't know what that means, go look it up. It's an interesting thing. I don't really want to talk about that right now. And then the last nasty one down at the bottom there is sodium hydroxide, and that is used in drain cleaner. Very serious stuff. Anytime you use drain cleaner in a sink to help unclog it, you really should be wearing something over your eyes. You should, if you can, wear some sort of rubber gloves, because you do not want to get drain cleaner directly on your hands. If you do, wash it off immediately, because as soon as it hits that water down in that trap, it starts to go through an exothermic reaction, gets hot, it starts to eat away at things, and it can be some pretty strong stuff. My father-in-law, just to give you a little side story here, he used to do contract work for a big paper mill company, and when they go to make paper from fresh trees, of course they've taken the trees, they've chopped them all up in the big chunks and chips, and then they put them into a great big huge tank called the digester. Now that's like your stomach, instead of digesting food with acid, this paper company would use a strong base, and they would use that base and all those wood chips and water in there to actually break down those chips of wood down to real fine fibers. And once it broke down to really, really fine fibers, then they could add bleach in there if they wanted to, and that would make it white, so that when they go to make white paper for us to write on, then it would, turn it that nice bright color for us. But he had to work inside one of them tanks after it supposedly was cleaned. And anyways, he was working there all week, and he was telling me that he had a brand new pair of leather boots with steel toes on there, and by the end of the week, all the leather had been eaten away off the outside of his shoes, and you could see the steel toe part of it, so that that base that was being used to help digest down that paper fiber, that was actually really strong enough to actually eat through leather, nice thick shoe leather, in about a week. All right, moving on. These are properties of bases. You definitely got to write these down. Now remember, an acid was sour. Bases are bitter. Okay, bitter. That's kind of easy to remember. B for base and B for bitter. And good examples, like you've got really dark chocolate, it's got that really bitter taste. Some people really like a nice dark chocolate. Pure cocoa powder is very bitter, which means it's got a lot of base in it. And cough syrup. If you've ever had that when you were a little kid and you had to take cough syrup, the part that you used to hate, you know, the nasty taste on there, that sour, or excuse me, that bitter taste, that was the part of the base that they had to use in that cough syrup. Base is also very slippery to the touch. If you've ever had to use bleach before, and if you get a little bit of bleach on your hands, on your fingers, and you rub your fingers together, it's very, very slippery. Now, it's important you to realize is that the base isn't actually slippery, okay? It's actually not but slimy, but what makes it feel slippery to your fingers is that bleach, when it gets on your fingers, it begins to eat away at the skin cells on the outside surface. And as it breaks the skin cells loose from your skin and starts breaking down your skin, as you slide one finger across the other, those are actually, the skin cells are actually now loose and they slide real easy. So to you, it feels like something really slippery and kind of like, ooh, weird, this feels slippery on my fingers, when actually it's eating away and releasing skin cells off the outside of your finger. So you better wash it off pretty quick. Now, back to litmus paper. This one's kind of weird because on this one, remember I told you different kinds of litmus paper. This one, you start with a red litmus paper, and if you stick it in something with base, it makes it turn blue. Okay? And the last little thing is as a proton acceptor. Now, one way I'm going to share with you on how to memorize a base is everything starts with the letter B. I remember base, I remember bitter, and I remember blue. Okay? So bitter, blue, base. Base, blue, bitter. Okay? You can memorize those pretty easily. All right, going on to the next thing. What happens if you take the world of strong acids and strong bases and you mix those two together? What exactly will happen? Well, the same thing happens every single time. I had a chemistry teacher years ago, and we were in there in college, and he took this strong acid and he dumped it on something and it ate it away. Then he took this base and he dumped it on something else and it dissolved that thing. And then he very carefully mixed an acid and a base in this beaker, and he stirred it around, and then we're wondering what in the world is going to happen. What did he do? He started drinking it. We're all starting to freak out. Like, what are you doing? You know, we thought something horrible was getting ready to happen. But actually, he was showing us the exact reaction that you see in front of you right now. He took a weak acid, HCl, and he took that sodium hydroxide, and he knew the exact balance to be safe with this. Mixed those two together, and he wound up, anytime you take an acid plus a base, you go through something called neutralization. And it always produces, always, when you mix an acid with a base, it's going to produce two things, water and salt. Okay, water and salt. Now, in this particular example that you see on the screen right now, that salt over there, that's NaCl, that salt is table salt. Okay, so you can actually consume that. We sprinkle that on our French fries. And you also need to realize that there are hundreds of different kinds of salts, most of which you do not want on your French fries at all, ever, ever, never, never. Okay, it's just that one particular example that you see in front of you. When you mix those two together, you're actually going to get water and actually get table salt. Okay, and the last thing I want to make sure you remember is that anytime you take an acid plus a base, you always get salt water, okay? You always get water and you always get salt out of it, okay? And this process, don't forget to write this down, is called neutralization, written down there at the very bottom there. So acid plus base gives you salt water, and it is always called neutralization. All right, thank you very much. Talk to you all later.